coding. Today we're going to look at another Leetcode problem called world search. This is another very high frequent problem, and it's pretty popular. It's a great way to understand DFS. It's a search problem. Let's look at the problem description. So we are given a vector of characters board, m by n grid of character board, and a string world. And we want to return a boolean to indicate whether this world exists in the grid. Now, how do we define whether this string exists in the grid? The world can be constructed from the letter sequentially from adjacent cells. So adjacent means it has 4 neighbors, right? Where adjacent cells are horizontally or vertically neighboring. The same letter may not be used more than once. So for example, if I have A, B, C, E, the board is constructed this way. The world is A, B, C, C, A, B, C, C, D, E. Obviously, this is in the grid. Let's look at another example. So we have C, it's also in the grid. And we have A, B, C, B. First, we find A, B, C does not have a B. Here we also have an A, but has no B. So it will return false. I think the problem is pretty standard. We have a well-defined input and output. Now the thing is, how can we construct the problem in a search manner, right? Like the input is basically we have a board to search, and we want to search a world in this board. So the basic idea is to use DFS to traverse. So we loop through this grid. As long as it starts with the world, then we just continue the search in a DFS manner. For a DFS, the time complexity would be, at each grid I have 4 directions, right? So the time complexity would be times 4. The space complexity depends whether we will use an auxiliary data structure. Normally might be a visited vector for board, or we can just modify this in place. So I'm just going to aim for the best scenario, whether we would modify the board while searching. Okay, cool. Yeah. Now let's